Doing a quick lesson on how we can make use of graphs on the graphing calculator, and I know we've probably all put in some graphs on the graphing calculator before. In particular, what we're going to do here is just, I'm going to state the importance of making sure that we know how to appropriately choose a window, and we'll get a little practice in that, and then see a useful technique where sometimes there are equations we solve that we just don't have the algebraic tools to do it. Like, there's a quadratic formula and we can complete the square, but there's not really a cubic formula. So like solving a general cubic equation is like a whole other kettle of fish. So sometimes you might encounter equations that are a little bit more difficult to solve, or that where our algebraic tools kind of fall short. So if you have a calculator, let's get it out. And oops. And if you're going to enter a function, just hit the y equals button. You might have some other functions in there, and that's okay. You could either clear them, or if you go over here, if you hit the enter button with this thing that's blinking, it will either, depending on the model, I guess you could change the color, or you should be able to turn it off. Hold on. Oh, that's when you do that. Okay. So let's plug in this function, right? So we have x squared plus 16x plus 72. And I think my window is set to the standard window, like from -10 to 10 on both axes. And that's doesn't really give us the best view here of the graph. Yeah.
Minus telling me that I have invalid dimensions.
That's because I'm guessing your window is set up wrong, or your plots are on. How about, what happens if you hit the second key and the y equals, so you get to go to stat plot? Or see how mine all say off?
Oh.
Do you have some that say on? So turn those off. If that happens, that should fix it. Yep. So back to this graph, I can't really say with certainty that I know exactly what this function. I'm only really seeing kind of one tail of it. So if I look at the equation itself, it's x squared plus 16x plus 72. The y-intercept is 72, and it definitely goes up from there. So we could, if you hit the window button, you can manually set what the window is. So, maybe I'll go from, let's see, if we look at the graph again, none of this graph seems to be below the x-axis either. So I'm going to go ahead and say, I think I could have maybe go from 0 to, 100. I'm just throwing in some numbers just so I can start. And sometimes we might refine this a little bit more. And then 0 to 100 is definitely what I wanted for the y values and not the x values. For the x values, I think maybe like minus 20 to 10. I'm going to try that first. Where it says x scale and y scale, that there's really no reason, we don't have to change that at all. That just tells us how often it makes a tick mark. Oh, and that looks all right. So we have a much better view of this function after adjusting the window. Are there questions about this process? I'm sure you've probably done this a bunch of times already, but okay. So now here's where using the graphing calculator can be particularly helpful, is to help us solve equations that our algebraic tools kind of leave us a little bit short. So there is like a procedure listed here, and I'm just going to kind of go through these steps by example. So let's say we want to solve the equation 3x squared minus x to the fourth equals 2 plus x. I think the simplest way to do this is to first collect all your terms on one side. Doesn't really matter which side, but you want to make sure you have an expression that's set equal to 0. So maybe if I subtract 2 and subtract x, then we get 3x squared minus x to the fourth minus 2 minus x equals 0. Then this expression on the left, I'm going to put that into my y1 editor. That's going to be my function. Minus 2 minus x. Okay. Now, if I hit the graph button, it's still got my old window in it, and I can just barely see a little tiny piece of this function here. So I'm going to go back. If I'm not really sure what window to use, I almost always just start at the standard window. So if you hit zoom, and on mine it's option 6, Z standard, that'll bring you straight to the minus 10 to 10. And that's not a bad window to view this in. Note that when we rearrange this equation, so that we're now looking for a solution to this equation, where is this expression that we put in our y1 editor, where is this equal to 0? Like, as a function, if this is my function, I want to know where that is equal to 0. On the graph, what I want to know is where does it cross the x-axis? So this is not a bad window to view it on. I can sort of tell it looks like it crosses the x-axis twice in a couple of spots. I want to kind of maybe zoom in just to get a nice sort of close-up picture of this. And one option you have to zoom in, you can actually draw a box around the area that you want to zoom in on. So if you hit zoom 1, now you have this little blinking cursor, and what you do is you move it so till it's in one corner of the box you want to draw. It's kind of like an Etch-a-Sketch type of thing. And once it's in one corner, you hit enter, and now you use the arrow keys to draw the box. Oop. I swear that this TI Smart View thing, it's kind of nice, but I think it takes me longer to do things on the app than it does on the actual calculator.
Quick question.
Yes.
What did you change the window settings to? Because mine was still on the 100.
So the first thing I did was I hit zoom 6.
Okay, seems.
And that should bring it back to the minus 10 to 10.
All right.
Okay. So I've drawn the box, and now I just hit enter. And now you're looking at the graph just in the box that you drew. So again, I could tell that there's 2 spots. And I want to zoom in on, or I want to figure out where are those 2 x coordinates where it crosses the x-axis. So in the calculator, if right above trace in blue, it says calc, or maybe in yellow, depending on the model. So I hit second calc, and I'm going to choose option 2 for 0. That means I'm finding a 0 of the function. Now what it does is it's going to ask you for 3 things: a left bound, a right bound, and a guess. So let's say I'm going to find the first 0 over there. I've got to, it's set to trace, so I'm going to move my cursor so it's somewhere to the left. Okay, so now it's blinking somewhere to the left. I hit enter. Now it wants a right bound, so I just move it somewhere to the right of that 0, and I hit enter. Now it wants a guess. There's no reason you have to put in anything. As long as there's only 1 0 in between the 2, just hit enter here, and it'll find it. So we get negative, it says it right below on the screen, negative 1.70211. And now there's one more. So if we go back to the graph, we just go through the process again, do second calc, tell it we're looking to find a 0, and now we just have to make sure we draw the left bound and right bound on the other side. Yeah, around the other 0. So somewhere to the left, somewhere to the right. There we go. We get a guess. And I get negative 0.7183. If you're like me, you look at this and you're like, well, that's an entirely unsatisfying way to solve an equation. I'm right there with you, right? Yeah, not satisfying at all. It's useful when we have to use it, but most of the time we're content to use awesome things like the unit circle or trig identities to help us solve equations, right? All right. There is not a this example was mostly this is kind of a cool tool that we have available to us. I will never give a question on a test that says use the calculator to solve this equation. That's never going to happen. Not with me. So, because I would never do that to you guys, right? I would want to make sure that you got some satisfaction out of solving these equations.